Right. So in today's class, we are going to discuss with the rest of the options available in the dimension designer. Okay. So in last class, we have created hierarchies also. I guess. Let me check. Yeah. Right. So in dim product dimension, we have created hierarchies successfully and we have tested the data. Correct. Now, in today's class, we are going to see how to do sorting and how to do custom sorting also in hierarchies or attributes, whatever it may be. So if I go to the browser tab, let me select the product hierarchy. Let me expand it. See, the first value comes here is bikes, components, clothing, accessories. Correct. So what is this order? Currently, it is taking the default order based upon the ID column, because we know that in last class we have discussed the backend column, whatever it may be, that is used as a ID column is a product category key, right? So if you go back to the table, if you go back to your dim product category table, let me expand the databases. Let me go to the AdventureWorks DW, expand the tables, then on the document. Just give me a second. So let's come back to the session. Sorry for that. Okay, so now let me go ahead and take the dim product category table. Let's use select star from category table. So if I execute this, so it is going to show me the category IDs. Okay, so what is the order? The order which is appeared in the attributes depends upon the category ID. See, 1 stands for bikes, 2 components, 3 clothing, 4 accessories. Same order it is following. That means the data is sorted based upon the category ID. So what if I want to change this order based upon the category name? So let me change this order. Order by, order by, I will use category name. Let's execute this. See, now I have changed the order based upon the category name. So accessories comes first, then bikes, then clothing, then components. Isn't it? So let me apply the same thing in the dimension also. So let's go back to the dimension structure. Right click on the dim product, go to the properties. See, in properties, uh, I'm sorry, not properties of dim product. Let's go to the product category. Select the product category, then go to the properties. See, here there is a attribute, there is a property called order by. See, order by property is having the item called key. Okay, by default it will be key. That means it is taking the ID column. Key means ID column. Order by attribute is nothing. So it is taking the sorting column as a key column. So let us select the named column. If I select the name column, then what will happen? For this product category ID, what would be the named column? Named column would be the category name. Key column would be the category ID. So earlier it was sorted based upon the category key. Now it would be sorted based upon the category name because I have selected name as a order by property. Okay. So now let's go ahead and right click and deploy it. Why it is taking too much time. Okay, we have Vaishnavi also. Right. Okay, so deployment completed successfully. So sorting is done. Let's go to the browser. So every time we need to reconnect. After reconnecting, see the moment I select the product hierarchy, see accessories comes first like this. Then bikes, then clothing, then components. So sorting order has been changed from ID to the name. Okay. So hi Vaishnavi. So just now we have discussed how to change the sorting order from default ID to named column. So that is what we did as of now. So very simple one. So anyway, I'm going to show you that. See, currently the data is by default it will be based up. It will be sorted based upon the category key. So what I did, I have changed it to name. Okay. So I simply go to the dimension structure. I right clicked on the category, product category column. Go to the properties. Now go to the order by. Here by default it will be key. So I changed it to name. Simple. That's it. Then the sorting order would be changed automatically. So sorting order will be changed based upon category name rather than category key. Earlier it was key, now it is changed to name in dimension. Okay. So this is what how to change the sorting order. This is fine. Then what if my client is asking something another requirement? So if I take this, select product category. Uh, so this is your, oh my god. So this is your category name. So your client is asking some another requirement. He do not want to follow based upon category ID or category name. He wants to make the custom sorting. Okay, custom sorting in the sense he will provide the order for you. Okay, so he wants to get the clothing value first. So order is changing now. He wants to get accessories in second position, and he wants to get components in third position, and finally he wants to get accessories in fourth position. So if you sort the data based upon category ID or category name, you will not get this kind of sorting order, isn't it? So this is called custom sorting. Your client is providing you the sorting order, so you need to do like that. So in this case, what you can do, you can create one dummy column with custom sorting order. Then you have to sort the data based upon that particular column. Okay, so the thing is, we need to create one dummy column. Let us say some sorting order. That is the column name. In that column name, we are going to use case statement in order to get this particular order. Then we will use it for the order for sorting purpose. Okay. So here in a SQL Server, generally what we are going to do, we will write case statement. Let's keep the case statement here. Case when case when category name is equal to clothing. Then one. When right. Second one is accessories. Let's keep the two components. Three accessories. Why accessories coming two times? Sorry. Clothing, accessories, components. Bikes missing, right? So let's keep the bikes here. Right. So let's end the case statement as sort ID, sort underscore ID. So this would be the alias name for this particular column. Let's execute it. See, we are getting dummy column here. We have created a dummy column called sort underscore ID. Now let's sort the data based upon this dummy column, whatever we have created just now. Order by sort underscore ID. See, so whatever your client is asking, same sort of order is provided here. Okay, custom. This is called custom sorting. We have created a dummy column and we are using it for the sorting purpose. How you are going to do that in the SSAS? Okay, so let's go ahead. Then open the data source view because we do not have this column. Sort ID column is not there. This custom sorting, for custom sorting purpose, we need to create a dummy column. So let's go back to the data source view. Then go to the product category table. Now right click on new named calculation. Right click on dim product category table header. Then select new named calculation. So what we can do, you do not select the select statement. You do not want the from clause. Only the case statement from the case beginning to case ending. You do not require this alias name also. Copy it. Now provide the name here, sort underscore ID. Paste that case statement here. Click on OK. See, one column is created here, sort ID. So if you want to test the data, right click on it and explore data. It is going to show you. So go to the last column. Last column is what? Whatever you have created just now. Sort ID. See? So it is working. We are getting the data. Now let's go back to the dim product designer. See, if you see that in the data source view, now it is showing that sort ID, right? Now I want to sort the data based upon sort ID. So before using that, what we need to do, we need to assign a sort ID column to the category key, product category key. Okay, because I want to apply sorting based upon sort ID. That is the reason. So let's go to the attribute relationships. I will explain this relationships after this sorting part. This is really important. So as of now, do not worry about this thing. So let's right click on product category, new attribute relationship, select the sort column. So here it is not showing because we haven't selected it. We haven't selected the sort ID. So let's drag it here. Now sort ID comes here. Go to the attribute relationship, right click, new attribute relationship, select sort ID, click on OK. See, it is assigned to the product category. Now let's go back to the dimension structure, right click on product category, go to the properties. Here, come back to the order by property. So in order by property, what you can do, select attribute key, order by attribute. In this property, you have to select that sort ID. This sort ID will not be appeared unless until you assign that value to the category key. Here we have assigned it, right? If you do not do like this, then you will not be able to see that in the drop down. That is the reason why we have assigned it. Okay, now what will happen? The sorting will be based upon the new column called sort ID. Let's deploy it. We made the changes, right? So deploy it and process it. Automatically processing also done. Deploying and processing. Go to the browser. See, order will get changed as soon as I click on reconnect button. See, this is what the order, right? Clothing, accessories, components, then bikes. Clothing, accessories, components, then bikes. Clear? Any doubts? Any doubts with the custom sorting? No, right? Okay, fine. Now let's go to the attribute relationships. This is really important. Second tab. Okay. Now, first of all, attribute relationships are nothing but relationships created among the attributes. Because product category is one attribute, product subcategory is one attribute, product is one attribute. So this will be created at the time of you are dragging the attributes into hierarchy. This is first level, this is second level, this is lowest level, granularity level. Okay. So when you create a product hierarchy, if you go to the attribute relationships, automatically this relationship will be built. This is the lowest level, granularity level. So if you want to see summarized data means totals. Okay. So if you want to see summarized data category wise, what are the top 10 products? So you want to get the sum of sales amount for the top 10 products product category wise. In bikes, what is the total sales? In clothing, what is the total sales? Like that. Okay. Now, generally, if you want to write a SQL statement in order to show the product category wise sales, then what you will do? You will apply group by clause based on the product category column, isn't it? And you will apply some aggregate function on total sales amount. Correct, right? So system is going to get the all detailed data, then it will apply group by clause based upon the category ID, then it will apply aggregate function on sales amount in order to get that summarized data. So let us say if you have millions of records in detailed data, so it will take a lot of time, right? In order to summarize the data and it has to show you the result, it will take a lot of time. If you have very less data, then it will not take that much time. So what if already I have some, let us say you have 1 million records, 1 million detailed records. Okay. 1 million detailed records to sum up the data. In second scenario, you have only 37 records to sum up the data. So which one is easier? 1 million records easier or 37 records easier? 37 records is easier generally, because already At one level, you have already summed up the data. That is nothing but subcategory. Okay. In first scenario, you have 1 million records. Those are individual detailed data at product level. At product level, you have the sales amounts, 1 million records. In another, in second scenario, you have total we have 37 subcategories, right? So already someone has summarized the data at subcategory level. So you have only 37 records. So now your client wants to see category wise data. So if you sum up the subcategories, you will get the categories, right? Isn't it? So summing up the 37 records is easier than summing up the 1 million records, isn't it? That is what exactly happened here. In attribute relationships, whenever you process the cube, I told you the advantage of the SSAS. Whenever you process the cube in backend, there are some tables will be created, aggregate tables or pre-calculated values. Okay, for aggregation purpose, there are some tables will be created, and those tables will be rebuilt every time whenever you process the cube. So those aggregation tables will have summaries. So if you have product category, product subcategory, and product, system is going to create a summarized data for product subcategory already. Because tomorrow if someone comes and asked for the product category wise summarized data, then probably it will jump to the subcategory and it will summarize the data rather than going to the product, rather than going to the detail level. Because if you go to the detail level at that point of time, it will take a lot of time, isn't it? So the advantage is here we have aggregation tables in the SSAS. That is the reason why when you simply drag and drop, and if you do the analysis, you will get the summaries within a fraction of seconds. It will not take that much time because already that summarized data will be available in the backend tables. That will be taken care by SSAS. Okay, no need to worry about that. So system will have different types of combinations. In different types of combinations, it is going to keep the summarized data. So that is what the advantage. So now if I come back to the query, if I simply drag the product category and if I want to see this category wise summarized data, then rather than going to the detail level, it will go to the subcategory and it will sum up that data and it will show you. It is lot of time saving, right? Performance will be increased. So when will it be done? Whenever you have this type of arrows. What is this arrow? This arrow is nothing but a relationship type. Okay, so it is transparent one. If you right click on it, if you go to the relationship type, see there are two types of relationship types, flexible and rigid. Flexible will be the default one, and always recommended that flexible should be the selected category. If you select rigid, then what will happen? It is turned into dark color. Clear? So what makes the difference? If I select flexible, what will happen? If I select rigid, what will happen? So I told you every time whenever you process the data in backend, aggregation tables will be rebuilded. That means whatever tables are there, those will be dropped and new tables will be created with the updated data whenever you have flexible. So process time might be late, might be more. Processing time might be more means latency is high. So it will take much time to rebuild the tables when you process the cube. That is one disadvantage, but still you have a lot of advantages because you will get updated data. You will get updated aggregated values whenever you have flexible. Whenever you have rigid, then what will happen? It will not think about the updated attributes. So let us say tomorrow someone comes and updated the new category in the product category column. That will not be considered here. So if any structural changes happen in the product category ID, that will not be taken care by this this attribute relationship. If you select the rigid, it will not take the structural changes into the consideration. So you will not get the updated data. Whenever you process the cube, it will not rebuild the table. It will simply update the data rather than rebuilding the table. If it is flexible, then it will rebuild the entire table. So you will get updated data. So that is the reason why we are not sure when will be the data is updated and when the structural changes are going to be happen in the back end. So that is the reason why always better to have the flexible. Yes, process time is more, but you will have a lot of advantage, and you do not you do if you do not want to take the risk of losing the updated data, then go for flexible only. If it is rigid, yes, process time is little lesser, but you will have a greater risk. If tomorrow structural changes happens at attribute level, that will not be taken considered. That is the problem. Okay, so always better take the flexible. Clear? So any doubts so far this attribute relationships part? It is purely for performance purpose. No doubts, right? Fine. So I have we haven't faced any problem here when creating this attribute relationships. Automatically system itself is taken care here. System is simply connecting product to the subcategory, subcategory is connected to subcategory. Fine, no issues here. But when you try to create the time dimension, you will face a problem. It will not create the proper relationships. So whenever we do not have proper relationships, it is going to throw a performance issue. So I'm going to show you at the time of time dimension, okay, what will happen. So now let us jump to the translations. Okay, translations is a concept where we can translate the data from English to Spanish. Not only English to Spanish, whatever data, but it will not exactly work as a Google translator. That means if you have English data, you will not be able to translate into any other language. There are limitations. So if your source table is having English data, both Spanish data and French data, you will be able to convert that English data into either Spanish or French, not any other language, because your source table is not having other language columns. That is the reason. If source table is not having any other language columns, only English data, then only you have to see the English data. That's it. So that is the reason why I told you it will not work as an actual Google translator. Whatever other language columns are available in our source tables, only those, it is limited to only those languages. That's it. So let's see the small example here. So let me go back to the, let me click on the new translation. Okay, the moment I take in new translation, let me select Colombia, Spanish Colombia. See, I'm selecting the language called Spanish Colombia, click on OK. Now, if you go back to the category table, see, in category table we have product category name, Spanish product category name, French product category name. So like that, for subcategory also we have Spanish and French data. For products also we have Spanish and French data. That means you have English column as well as Spanish and French columns also available. So now you will be able to convert this data into Spanish for category, subcategory and product. Okay, rest of the columns are not having that data. So let's select the product. So for product, let me provide name. See, product is nothing but a product name, right? English product name. So in Spanish, uh, even we don't know what we can call in Spanish. For product, let us assume that AAA is the product. We call product as AAA in Spanish. Okay, let us assume like that. Okay, let's click on this button. Select the Spanish product name here. Spanish product name. Click on OK. Now let's come to the subcategory. For subcategory, I'll name it as triple B. Let us assume triple B is the subcategory name in the Spanish. Select the Spanish product subcategory name. This is the actual name actual column we are going to assign here. And let's go to the product category. Let's call it as triple C. Select Spanish product category name. Click on OK. That's it. Okay, for only those three columns we have the Spanish data. So let us right click on it and deploy it. Completed. Go to the browser. Now let's reconnect. See, the moment I select the product category product hierarchy, it is showing clothing, accessories, components, bikes. It is in a English language only, because the language is default. Default English language is United States English. That's the reason why it is showing the English data. So let me select the Spanish Colombia. We have selected Spanish Colombia, right, at the time of creating the translation. The moment I select the Spanish Colombia, see, data is changed to Spanish data. We have bikes. If you expand that, you have subcategories in the Spanish data. If you expand that, for some products we do not have Spanish names. Whatever products which are having names will be shown in the Spanish. See, here it is having Spanish names. That's why it is showing like that. For the columns which are not having any Spanish names, like model name and all, for this again it will be in English only. Okay. See here, rather than showing the category, product, it is showing triple A. Rather than showing the triple B, rather than showing the subcategory, it is showing triple B. Clear? So this is what the translation concept. Any doubts? Okay, right. So let's move to the next dimension called time dimension. Okay, so we are done with the first dimension, product dimension. Let's close this. Now let me right click on dimensions, new dimension, click on next, use an existing table, click on next, select the table called dim date. Okay, we are going to build the time dimension with the help of dim date. So key column will be automatically selected, that is date key. Click on next, expand it. Now let's check the data first. Dim date, select star from dim date. See, first one is date key. Date key is a ID column, okay? And next column is full date alternate key. Full date alternate key is nothing but date format of the date key. That means this is the actual day information. It is in a date format, it is in a number format, if you observe that. See? But this will be your primary key column, and this will be your date column, date ID, date value. Okay, that individual day. We require this column. And we need month number of year, quarter number of year. See, here we have month number of year, in which month that particular transaction happened. Calendar quarter, in which quarter that transaction happened. Calendar year, in which year that transaction happened. See, so we need all these attributes. Let's go back to the dimension designer. Let's go to select full date alternate key and month number of year. Where is that? Month number of year, then calendar quarter, calendar year. So these are the attributes I want to select here. Now click on next. Provide the name dim time. Dim time, click on finish. The moment you click on finish, it is going to create a dimension. Okay, fine. Now let's deploy this in order to check the data. Right click on it, deploy it. See, deployment is completed successfully. Go to the browser. Now reconnect. Now check the calendar quarter. How many quarters are there? So let's come something like this. So let's come to full date alternate key. So it is going to show you day wise data. This is fine. Okay. Let's come to month number of year. How many months are there? 12 months are there. Let's come to calendar quarter. 4 quarters are there. 1, 2, 3, 4. Let's come to calendar year. How many years are there? 2005 to 2010. That means 6 years data is there. So for 6 years data, how many quarters should be there? 6 fours are 24, right? And how many months? 6 12s are 72. But how many quarters are showing it? It is showing only 1, 2, 3, 4. Only 4 quarters. It should be 24 quarters. Rather than showing 24, it is showing only 4 quarters. If you go to the month number of year, rather than showing 72, it is showing only 12 months. What happens? We know that always system is going to use the distinct keyword while loading the data into the dimension at the time of processing the cube, isn't it? So if you want, I can show you that. Go to the not properties, go to the uh, deployment process. Let's process it manually. The moment you click on run, see processing succeeded. Let's go to the dim time. Under dim time, see we have calendar quarter. If you go ahead and copy the SQL query, see, copy it, paste it here. See, for calendar quarters, it is taking the distinct values. So even though quarter 3 is appeared in all the years, it is not showing the quarter 3 of each and every year. It is showing only one unique value. That's it. You understood the concept, right? So if I uncomment, if I comment the distinct, then if I execute it, see how many values are there. 2191. This is also not correct for us. So our requirement is what? We need to identify each and every quarter available in each and every year. That means your quarter value should be in combination with the year value. After distinct, if you keep calendar year, so what is this? Let's go to the dim date, expand it, go to the columns. Now see, let me identify each and every quarter available in each and every year. So let's go to the calendar year. If you drag this calendar year here and keep the comma after that, now execute this. Is it correct or not? See how many quarters you are getting. 24 rows. 24 rows. Okay. So let me make it order by 1 comma 2. That means year and quarter. Execute this. Now you will understand very properly. See, in 2005 we have first quarter, 2005 second quarter, 2005 third quarter, then fourth quarter. Again 2006 1 2 3 4, 2007 1 2 3 4, 8 9 10. So total you will get all the 24 rows. This is perfect, isn't it? So what we did, we have used the calendar year in the combination so that we will get each and every quarter that is available in the each and every year, isn't it? You understood this point, right? Clear? Right. So let's go back to the month number of year also. Month number of year. See here, if you check this, see, let me copy that and paste it here. If I execute this, it is showing only 12 months values, isn't it? So what if I include calendar year, comma, calendar quarter, comma, then month number of year, and order by 1 comma 2 comma 3, because I want to select each and every month. I want to identify each and every month available in a calendar year. Even though you select only calendar year and month, that is also fine, but for more clarity I want to include calendar quarter also. See, in 2005 first quarter, first month, first quarter second month, first quarter third month, after that in 2005 second quarter, fourth month, fifth month, sixth month, like that. So how many rows you are getting? 72 rows, because 6 12s are 72. Clear? So this is what the real scenario. So we need to modify SSAS logic. We cannot modify this distinct keyword. We cannot modify this SQL statement, because system will automatically will take that. But there is another way. We can identify each and every month and each and every quarter available in a year. There is another way we can do that. So just give me a second. I will come back and show you that. So let's go back to the dimension designer. Here, what I want to do, we know that both date key and full date alternate key are same, but it will be in a number format, it will be in a date format. Okay, so what I want to do, I want to delete this full date alternate key, and I want to apply that full date alternate key as a named column for the id column, that is your date key. Okay, right click, date key properties, let me change it to simply date, that's it. Okay, otherwise you can say day. I renamed it to day simply for understanding purpose. Now let's go to the key columns. In key columns, what is the id column in backend? Date key. Fine. In named column, nothing is there. Let me select full date alternate key as a named column. Simple. Okay, now come back to the calendar quarter, go to the properties. So let me select, let me remove the calendar. I simply use the quarter, the name is quarter. Okay, after this, after changing the name property, go to the key columns. In key columns, the actual backend column is id column, that is nothing but calendar quarter. Now what I want to do, I want to include calendar year also, in order to identify each and every quarter in a year, right? So we need to get the total 24 rows like this. Okay, for this purpose, here you have applied calendar year also in the select statement. So in the same way, I will include the calendar year in the key columns. But you have to remember one point. Whenever key columns are having more than one column, it will be turned into a collection the moment you click on OK. Then name column should not be none. If you have more than one column in the key column, when it is turned into collection, it should be, there should be one column specified for the name column. It shouldn't be none. Otherwise, you will get an error. You cannot deploy the cube. Okay. So let me show you that. So go here and let me select calendar year. Make it in a first priority. See, calendar year, under which we have calendar quarter. So you selected both calendar year and calendar quarter in select list. The moment I click on OK, it is turned into collection. See, because we have selected combination of the columns here. Okay, now I I haven't selected anything for the named column. So if I deploy it, it is going to throw an error. Let me deploy it. See, the moment I deploy it, it is throwing error. Dimension attribute dim time and attribute name is quarter. The name column should be defined because there are multiple key columns. So it is clearly saying the error, isn't it? There are multiple key columns are available. What are the multiple key columns? Here you have both calendar ID, both calendar quarter. System doesn't know which column should be considered as a named column. If you have only one column, it will be default considered as a name column, even though you haven't selected anything here. But it is in a dilemma. So we need to select calendar quarter because we want to show calendar quarter, right? So let's select the calendar quarter, click on OK. So in named column, I have selected calendar quarter, but in key column, we have selected both calendar year and calendar quarter in order to identify each and quarter in each and every year. Let's do the same thing for the month number of year also. Go to the properties. Let me change the name by simply having month. That's it. Let's go to the key column. Here, what we need to do, we need to select calendar year, calendar quarter, then make the calendar year in the first position, make the quarter in second position, then the month number of year. So let's click on OK. It is turned into collection. Now go to the name column. So what value you want to show it as a named column? Month number of year. Let's select it because that is the original column, right? So month number of year, click on OK. That's it. Okay, let me change the name for the calendar year. Simply I will remove the calendar. That's it. We do not do any modifications for year. That is not required. So let us deploy it. It is done. Go to the browser, reconnect. Now select the day. The moment you select the day, it is going to show you the detailed data. Fine, day wise information. Go to the months. See, it is showing 1, 2, 3, 4. Total how many? 72 values are there. 72 months it is showing. Go to the quarter. See, it is showing all the 24 quarters. Year. All the years. Clear? So, let's go ahead and create a hierarchy. Okay. So, let me take the first hierarchy level as year, under which quarter, under which month, under this day. Day is the lowest level and granularity level. Okay. Now, let me rename it to, you can rename something like this by pressing F2 also. Let me rename it to time hierarchy. Simple. Now, see, it is going to give you some sort of warning message. What is that warning message? If you read that, attribute relationships do not exist between one or more levels of this hierarchy. This may result in decreased query performance. It is clearly saying that attribute relationships are not properly designed in this hierarchy. So due to that, query performance might be decreased. Why query performance decreased? Let's go to the attribute relationships. I told you, right? I'm going to explain attribute relationships more at the time of time dimension. So this is what. See, for product dimension, it is clearly designed, properly designed automatically. Product is connected to subcategory, subcategory is connected to category. Fine. But here, day is the lowest level. This is the granularity level. And day is connected to year, day is connected to quarter, day is connected to month. What if I want to get the year-wise sales report? Year-wise sales report. Then what it will do? Day is directly connected to year. That is the reason why if I want to see year-wise sales report, it will go to the day. That means lowest level. It is going to sum up all the detailed data and it will give you the result set. How much time it will take? per day billions of transactions will happen across the globe, isn't it? So it is going to take all the data for the throughout the year and it will give you the result set. Lot of time it will take, isn't it? Now what if I want to see quarter wise sales report? Then again it will go to the lowest level. It will take much time again. For monthly report also it will go to day. What if I want to see year wise sales report, already there are values, summarized values for quarter are available in the aggregate table. Is it advantage or not? Already quarter wise sales information is available in the aggregate table. Rather than going to the day wise sales, it will go to the quarterly report and it will sum up the values and it will show you year wise sales report. Likewise, if you want to see the quarter report, already if monthly values are available in the aggregate table, rather than going to the day level, it will go to the month level and it will sum up them. So summing up the quarterly values and monthly values are very easy than going to the day wise, right? That is what will happen in the aggregate tables. So, but we need to properly design that. So let us change the relationships here. Otherwise, system by default will go to the lowest level only. So right click, see, day should be connected to month, month should be connected to quarter, quarter should be connected to year. So let's right click on month, new attribute relationship. Let us select quarter here because month should be connected to quarter, right? So month to quarter, click on OK. Now quarter should be connected to year. Right click on it, select year, click on OK. See, now this is perfect. So whenever you process the cube in backend, aggregation tables will be rebuilt with the combinations like this. So if you want to see year wise data, it will not go to the day, it will go to the quarter. If you want to see quarter wise data, it will not go to the day, it will go to the month, like that. Okay, any doubts? Because see, the warning message is gone now because relationships are proper, so it gives you query performance high. Any doubts? No doubts, right? So this is what about time dimension. So let's right click on it and deploy it. Go to the browser, select the hierarchy. We have created the hierarchy, so let's reconnect it. Go to the time hierarchy. Now check it. See, it gives you pure drill down effect. In 2005, yes, we have quarter 1, 2, 3, 4. If you expand the first quarter, it is going to show you the related months 1, 2, 3. This is January, this is February, this is March. If I expand the January, then it is going to show you the day wise data. Pure drill down effect, right? But your client is little confused. Hey, how about this 1, 2, 3, 4? So I'm not able to understand this 1, 2, 3, 4. Rather than we are having this 1, 2, 3, 4. So what if I have something like this? Clients might be asked this kind of questions. Quarter 1, okay, or quarter 2, quarter 3, quarter 4. Even for month also, no, something like this. They want first year, then hyphen, then quarter 1. They want the values like this. Okay, and for month also they want year value first, then hyphen, then January, February, something like this. So if you expand the month value, it should be something like 2005 January, 2005 February. It should be 2005 quarter 1. Clear? So this type of requirement they ask you. So how you are going to implement that? Because we do not have this type of columns, right? We do not have this type of columns in our attributes. So what we need to, whenever we do not have the columns, we need to create a new columns. We need to create a dummy columns like earlier we have created. So let's go back to the SQL Server. This is our table name, right? So let's select table name. Here, let's come back to the first requirement. First requirement is what? We need to combine year with quarter 1. So we have calendar year, comma, calendar quarter. Now let us execute this. See, we have calendar year and calendar quarter. Now we need to make this in this format. So we need to concatenate calendar year with the hyphen. Okay. So let's remove the comma here. Let's concatenate this with hyphen. Again, put the plus. See, it is showing you data, but this is not correct, isn't it? This is not correct. So what we need to do, you want to convert this entire thing into string, because hyphen is a string value, right? So when you concatenate number value with string, you have to convert this number into string before concatenating it, isn't it? So the data type is what? Small int. For calendar quarter also it is tiny int. So let's convert this into string first. Okay, convert what is that? Calendar year, right? So let's convert this into char 4 with the comma. Now use this for calendar quarter also. Let's convert this. This is also in a tiny int. Only one digit is enough. Now what we need to do, we need to have, sorry, quarter hyphen. This is missing. So let's concatenate this also. Now let us check it. Order by calendar year, comma, calendar quarter. See, now this is perfect. 2005 quarter 1, something like that. If you go to the rest of the values, see, 2005 quarter 2, like that. 2010 quarter 4. So this is perfect, right? So let's get back to the second requirement also. Second requirement is what? 2005 January, something like this. So let me copy this entire thing. So here, rather than using this entire statement, so what I will do, let me remove this. So I will take month number of year. Now we have direct name also, month, English month name. Yes, English month name. So this is already in a string format. So let's use the direct column. Execute it. See, we are getting 2005 January, something like this. Clear? So this is the requirement we are asking, right? So year value, then month name value. Okay. Now let's go back to the data source view, because we need to create dummy columns. So let's go back to the data source view. Then right click on dim date, right click on this table header, then select new named calculation. Okay. So here what I want to do, first one is quarter related, right? So quarter description, quarter underscore full description. Let me copy only this part. We do not want select statement, we do not want from statement. Okay, copy it, paste it here, click on OK. See, quarter full description created. Again right click on it, new named calculation, month full description. Let's copy this. For month also, copy only expression. Click on OK. Now right click on it, check the explore data. Go to the last columns. See, quarter full description, month full description. So it's working. Let's go back to the dim time. So we have assigned named column for the quarter, that is calendar quarter, right? So if you go to the named column, it is calendar quarter. So rather than using the calendar quarter, let's select the quarter full description here. Just now we have created it, right? See, quarter full description. Let's do the same thing for the month also. Go to the named column, select the month full description. Okay, no need to grab them here. No need to grab them. So directly you can utilize them. So let's right click on it and deploy it. Go to the browser, reconnect. Now see, the moment you expand 2005, you are getting quarter 1, quarter 2, quarter 3, quarter 4. When you expand the quarter 1, so it is showing 2005 January, February, March. When you expand it, you will get the detailed data. Clear? So this is what the advantage of creating the dummy columns according to the requirement. Any doubts so far? Okay, right. So let's close this dim time. So let's create one more dimension called customer dimension. Okay, so let's click on new dimension, click on next, use existing table, click on next. So main table would be dim customer this time. So click on next. See, we know that dim customer is connected to dim geography. That is the reason why it is showing dim geography here. But I want to create separate dimension for the dim geography. So I don't want to continue this. So let's uncheck it. Click on next. Now let's see the add customer key. Customer key is a primary key column. Here we have first name different, middle name separate, and last name separate. So my client wants to get the full name column here by combining both first name and last name. Okay, so that is the reason why what I want to do, I will not select them here. Okay, I'm going to create one dummy column by concatenating both first name and last name. Then I will assign that full name column as a named column for the customer key. Clear? As of now, let me select only marital status, gender. That's it. I don't want rest of the things. Okay. Here, automatically geography key is enabled, but let it be like this. We require that. Okay, because this table is having relationship with the geography table. That's the reason why this geography key is required. Click on next. Dim customer would be the name. Finish it. Right. So let's deploy it. So deployment is done. Now what we need to do, we need to change the we need to create a full name column, right? So let's go back to the AdventureWorks, right click on dim customer on this table header, new named calculation. Here what I want to do, I want to get full name. So first name plus space, then last name. So let's click on OK. Let's right click on it and explore the data. See, we have first name John and Young. So go to the last column, John Yang, like that. Okay. So we have full name column here. So let's go back to the dim customer, right click on customer key, go to the properties. So here what I'm going to do, let me remove the name key, keep the customer, that's it. Go to the named column. Here I will select full name as a named column. Simple. Just give me a second. So let's go back to the data. Let's deploy it first of all. Let's go to the browser, then reconnect. So if you check the customer, see, rather than showing the customer ID values, it is showing full name column. And if you go to the gender, it will give you FM. F means female, M means male. If you go to the marital status, it is going to give you MS. M means married, S means single. But your customer, your client is going to ask you another requirement. He wants to get the full description of it rather than having MS. For the gender also, rather than having FM, he wants to get the full description, whether female or male, something like that. But we do not have that kind of full description columns, right? So what we need to do, whenever we do not have that kind of columns, we have to create dummy columns. So in order to create dummy column, let's go to the dim customer table. So here we have dim customer table. Expand the columns. See, this is the gender. Let's drag the customer table name. Select case when. Let me drag the gender also for understanding purpose. Case when, gender, when, okay, when gender is equal to M, then male. Else female. Now another statement. Now check this. See, whenever we have M, it should be male. Whenever we have F, it should be female, right? So same thing. Let's copy it and paste it here. Let's use the marital status. So when it is M, it should be married. When it is S, it should be single. Let's execute this. See, got it. So now let's go back to the data source view. Right click on dim customer, click on new named calculation. So let's name it as gender description. Here I will copy only this select statement. That's it. Sorry, case statement. Click on OK. Right click on it again. For marital status, copy only this case statement. Let's check the data. Explore data. Go to the last columns. See, we have created full name, we have created gender description, we have created marital status. Simple. So close this. Let's go back to the dim customer. Now right click on gender, go to the properties, go to the name column. Here let me select gender description, click on OK. So named column would be gender description. For marital status also, we should select marital status description. Let's deploy it. Before doing that, let us create the hierarchies also. Here we are going to create more than one hierarchy. So one is gender wise, another one is marital status wise. Okay, let me drag first hierarchy, under which let me drag customer ID. So gender wise, how many customers are there? Rename it to gender hierarchy. Let me drag one more hierarchy for marital status, drag the customer into it. Okay, so marital status hierarchy. Simple. So two hierarchies we have created here. Right click, deploy it. So go to the browser, let's reconnect it. Go to the first hierarchy, gender hierarchy, under which see how many female customers are there. You can expand that. These are all female customers. How many male customers? See, these are all male customers. So you can do this kind of analysis. That is the reason why we are creating this kind of hierarchies. For marital status, how many married customers are there and how many single customers are there. Clear? So any doubts while creating this dim customer dimension? Fine. So let's go back to the fourth dimension. This is the last dimension. So we are going to create a geography dimension. Select the table called dim geography. Click on next. So here we are going to select state province code, country region code. See, actually I should have city, state province name, then English country region name. These are the three columns I require in order to do analysis. But I am selecting only ID columns. Geography key, I will assign city as a named column to the geography key. I will assign state province name as a named column to the state province code, because this is ID column. You will not have any duplicates here. And I will assign country region, I will assign English country region name as a named column to the country region code. Rather than selecting them and again deleting them, I'm not selecting the named columns first. I'm simply selecting only ID columns, then I will assign these respective columns to the ID columns. Okay, so let's click on next. The name is dim geography, click on finish. So let's right click on it, right click on country region code and go to the properties. Let's change the name simply region country. That's it. Let me remove region code, and we want to assign name column country English country region name. See, this is the named column, so it is going to have actual country name. Right click on state province code, go to the properties, remove the province code here. Then named column should be what? State province name. State province name. Click on OK. Now select geography key. See, I told you I'm going to assign city to the geography key. So that is the reason why I'm going to change the name also for our understanding purpose. But the actual name is what? Geography key. You have to remember this point because it is really important. I'm changing it to city, but the actual name is what? Geography key. Okay. Named column would be city. Click on OK. Now what I want to do, I want to create a hierarchy also. Country, under which state, under which city. So let's name it geography hierarchy. See, hierarchy is not in attribute relationships are not in a proper position. Go there. See, if you want to see country wise sales information, it will go to the city lowest level. It will take a lot of time. If you want to see state wise, again it will go to the lowest level. So rather than connecting like this, city should be connected to state, state should be connected to what? Country. Let's change the relationships like this. Now this is perfect. Clear? So now we are not having any warning message here. Let's deploy it. Now go to the browser, reconnect. Let's select the geography hierarchy. See, Australia. Now Australia, under which we have respective states. If you expand the state, you will get the city information. Clear? So this is what the geography dimension. Okay. Yes, we are good with creating all the dimensions. Uh, let's uh, uh, let's let's create the cube also, but it will not take that much time. So I'm going to wind up the session in next 5 to 10 minutes. So we are almost done with the cube. So only one part is left. So we are done with all the 4 dimensions. Right click on cube, click on new cube, click on next, then use the existing table, click on next, then select the table from which we are going to build the facts information or fact measure group information. So this is the table we are going to use, right? Measure group table, fact internet sales. Select that, click on next. See, in this table we have a lot of measures, but we do not want to concentrate on all the measures. We want only order quantity and sales amount. That's it. Only 2 measures. Click on next. Now these are the available dimensions which we have created so far. So we need all the dimensions. Click on next. Now uncheck this because we don't want to create a new dimension with the help of fact internet sets because we have already created enough dimensions. That's it. Uncheck. Click on next. Now provide a name for this. Cube name. Sales cube. SSAS underscore class 23. See, these are the dimensions. These are the measures we have selected. This is the cube name. Click on finish. The moment you click on finish button, see, it is going to give you the designer, cube designer. So when you click on OK button while creating the dimension, you will be able to see dimension designer with 4 tabs, right? So same thing, cube designer. See, 10 tabs are available. Cube structure, dimension usage, calculations, then KPIs, actions, partitions, aggregations, perspectives, translations, then browser. So total 10 tabs are there. So I'm going to explain each and every tab. Okay. Then we will be able to finish the SSAS. So, but as of now, whatever rest of the dimensions are there, these are all related to performance, increasing the performance of the cube. These are all additional features available in the OLAP cube. But as of now, whatever you did, you are almost done with creating the cube. You will be able to analyze the data, except a small change. See, we need to set up this dimension usage. After that, you will be ready to design the, you will be ready to browse the cube. That means you can analyze the data available in the cube. Okay. So small modification. Here, see, how many dimensions are there? Dim product, ship date, due date, dim customer, order date. No, we have created only dim date, right? We haven't created ship date, due date, and order date. Where is dim date? Dim time, dim time dimension is missing here, and geography dimension also missing here. Why? Because your fact table is connected to the dim date 3 times based upon order date key, based upon ship date key, based upon due date key. We do not want ship date key and we do not want due date key. So right click on it and delete it. Due date also, we do not want this. Okay, we need only order date. So let us rename it to dim date or simply dim time. This is what your time dimension. Okay, this is your time dimension. So you have 3 dimensions: dim product, dim customer, and dim time. Then how about the 4th one? Add cube dimension, select dim geography, click on OK. Simple. So now you are having all the 4 dimensions and measure group. So if you expand the measure group, you will have 2 measures: order quantity, sales amount. If you expand the dim product, you will be able to see the product hierarchy which you have created. And if you expand the attributes, you will be able to see the different attribute names. like that for each and everything. See, clear? Now let's go to the dimension usage. In dimension usage, this is really important. You have measure group called fact internet sales, and you have 4 dimensions. So you have to make a join between both dimensions and measure groups. Yes, there is a join between dim product and fact internet sales measure group based upon the column called product key. How do you know that? Click on this ellipsis button. See, there is a regular relationship. Regular means this yellow color one is your fact table and this blue color one is your dimension table. So dimension column, dimension table also having the same column product key. Measure group also having the same column product key. See, this is your dimension table, dim product. Measure group table is what? Fact internet sales. Common column is what? Product key. That is the reason why relationship is regular. So no need to do anything here. Dim customer, open it. This is also regular. See, your dimension table is dim customer, fact table is fact internet sales, and common column is customer key. Click on OK. Dim time. For dim time, see, dim date is the dimension table, fact table is fact internet sales. Date key is the dimension column. In your dimension table, you have date key as a primary key column. In your fact table, you have order date key. So based upon this join, you will be able to do the relationship regular. Fine. Then how about the last one? Dim geography. See, dim geography automatically not picked up here because it is not having direct relationship. See, if you see the dim customer and if you see the dim geography, what happened here? Let me go back to the AdventureWorks DSV. Here, fact table is directly connected to the dim customer and dim customer is connected to dim geography. There is no direct relationship between dim geography and fact table. Okay, there is an indirect relationship through intermediate table called dim customer. This is intermediate table, this is your reference table, and this is your fact table. Clear? So indirect relationship exists between both fact table and dim geography. That is the reason why it is not automatically picked up the relationship. So click on it, select the referenced. So why I have selected reference? Because this is your fact table, yellow color one. Whatever dotted line showing here is an indirect relationship between fact table and your reference table. And whatever thick line, it is indicating that direct relationship between fact table and your intermediate table. So this is your customer table and this is your dim geography table and this is your fact table. So indirect relationship between your dim geography and fact table. That is why dotted line is there. Okay. Now reference dimension is what? Dim geography. Already you selected it. Intermediate dimension is what? This one, dim customer. Let us select the dim customer. Now reference dimension attribute. That means in your dim geography, there should be a column that makes join between your intermediate dimension and reference dimension. That means dim customer and dim geography. What is the common column between both of them? I showed you. There is a geography key, right? Geography key. We have renamed it to city. At the time of creating the geography dimension, we have renamed it to city. But the actual name is what? Geography key. In customer dimension also we have a geography key, foreign key column. Based upon that relationship, we are going to make a join here. See, even though it is city, but the actual name is what? Geography key. Try to remember this point. Okay. Go to the intermediate dimension. This is your customer table. In your customer table, we have a geography key. Now it makes a join. So click on OK. So if you want to see that, if you go back to the dim geography key, see, it says city, but if you go to the properties, it is going to show you the actual name, geography key. Clear? That is what I am trying to say. Now we are done with everything. Your cube is ready. Let's deploy it. Let's deploy it. See, deployment is done. This is just like a browser tab we are using in the dimension. So let's reconnect it. See, now it is going to show you the cube. You will be able to do the analysis here. In cube browser, you will be able to test the data, expand this. See, for KPIs, we haven't created any KPIs. That's why nothing is there. Let's expand each and everything. See. So if you expand customer attribute, let us say, then it is going to show you all the members. See, whatever data that is there, it is going to show you all the members, all members. See? Clear? So, and you will be able to see the hierarchies also. If you expand the gender hierarchy, see, under all you have female and male. When you expand female, you will have all the female customers. So this is common for everything, all the dimensions. Now what I want to do, simply I will drag and drop and I will do the analysis. So rather than writing the very big SQL statements, so what I will do, I want to analyze the sales amount, drag it. I want to analyze the order quantity, drag it. Now I want to analyze this information time hierarchy wise, then drag it here. By simply dragging and dropping, you will be able to see all the summarized information. See, in the year 2005, for the quarter 3, for the month July, on this particular day, this is the sales amount, this is the order quantity. 5 bikes were sold. Okay, what are those bikes? What is the category? What is the subcategory? If you want to analyze that information, then go to the dim product, and here you have product hierarchy. Then simply drag that hierarchy. See, you will be able to drill down that information further. Under bikes, under mountain bike subcategory, this is the product, and these are the 3 bikes were sold. Clear? So this is the way we are going to analyze the data. So now I told you the advantages of SSAS, slicing and dicing. Slicing means you will be able to create a slice. You will be able to create a subset of the whole cube. You can apply where condition on the whole data. How you are going to apply the where condition? So whatever data I'm showing right now, this is related to all the data. So what if I want to further filter it out based upon the customer gender? Then go to the filter, select dim customer. Here select the attribute called gender. Then select equal operator, filter expression. Select only female data, click on OK. See, now whatever data shown here, totally related to female customers. This is the way we are going to create slicing. Very simple. By simple dragging and dropping, you no need to do anything here. So this is from bits point of view. That means SSDT. In SSDT we have browser. That is the reason why you will be able to browse the cube. So what if clients do not have this Visual Studio? If they have only Excel, because generally people will do all this analysis using Excel only. They will do Power Pivot and all using Excel. So simply you can click on Excel so that it will be available in a Excel format. But in 2008 R2 we do not have this facility. So if you do not have this facility, how you are going to provide access to the client in order to access this SSAS OLAP cube? Sorry for that. Now let's go to the Excel. This is really important because we have another way to analyze the data which is available in the OLAP cube. After this we are going to wind up the session. Okay. Right, so let's click on Excel. Now go to the, let me close this. Let's go to the data, then go to the from other sources. Let us select from analysis services. Click on that. Now provide the server name. Sudhakar is the server name. This is your analysis server name. Okay. Click on next. Now select the database. SSAS class 23 is our database name, and this is the cube name. A sales cube SSAS class 23. We have created just now, right? Now click on next. Then enable always attempt to refresh this data. Then click on finish. So if you want to create it in a new worksheet, then you can select the new worksheet. Otherwise, you can click on OK. So it is going to create a pivot table here. So filters, columns, rows, values. These are the four areas where you can drop the values. See, I want to analyze order quantity and sales amount. The moment you select them, automatically it will come here. Okay. Now, what I want to do, I want to analyze this data overall gender wise, right? So let me keep the gender in filters, report level. Then let me keep the time hierarchy in columns, and let me keep the product hierarchy under rows. See, clothing, accessories, bikes wise it is showing the data. For 2005 we do not have any data for clothing and accessories. We have bikes data. So if you expand the 2005, for third quarter, fourth quarter we have data. If you expand the third quarter, then you will be able to see the July, August, September data. When you expand July, you will be able to see day wise data. If you remember the matrix report in SSRS, we did the same thing, right? But how many expressions we write over there? We created a lot of column groups, and visibility properties has to be set, isn't it? So a lot of things. But one problem is there. So if you observe the currency data, see, it is not in a proper format. So what if you want to change the proper format? If you want to convert it into dollar format, okay, if you want to apply 1000 separators for the numbers, then go back to your cube and right click on it. Right click on the sales amount, go to the properties. Now apply what is that? Format string. Let's apply it and go to the order quantity, go to the properties, format string, select 1000 separators. That's it. Now deploy this. Completed. So let's go to the browser. Now reconnect. Let's see the measures. Here it is not showing any difference. Let's check it on the refresh all. The moment you refresh all, see, the data is turned into formats. Proper formats are showing now. In Excel, you will be able to find out here. So this is another way of browsing the cube. You can do any analysis. So let me remove the product hierarchy and I can go ahead and select the geography hierarchy. See, Australia wise. In Australia, again, New South Wales. So this is the Coffs Harbour. In Coffs Harbour in 2005, this is the amount. So what if I want to see the detailed data? This is a summarized data, right? So if you want to see the detailed data, just simply double click on it. One separate sheet will be created with the detailed data. See, on fingertips you will be able to see the analytics if you want to drill down the detailed data. That is what the advantage of doing the OLAP cube. You can delete it or you can save it. Clear? Now this is second way of browsing the cube. First way is using browser tab in the Visual Studio. Yes, we can browse the cube. And second way, generally people will use this way only. Using Excel, you will be able to analyze the data. And another way is you can connect to the SQL Server analysis services. Let's go ahead and select the analysis services. Click on connect. Select the database class 23 under which and expand the cube. So this is your cube, right? Expand it. Now right click on this cube and click on browse. So using SQL Server Management Studio also you will be able to browse the cube. These are the three ways. Simple thing, same thing, whatever you have done over there. So you can do everything. See, clear? Any doubts so far? No, right? Fine. So in tomorrow's class, what I'm going to do, I will start with the MDX expressions, okay? Because after this dimension usage, we have a tab called calculations. So in order to explain calculations, first of all, let me help you with the MDX expressions, multi-dimension expressions, okay? So how to write MDX expressions and all, then we will see calculations and KPIs. Because these both are related to MDX expressions only. That is the reason. Let me explain MDX expressions in the first part. Then we will move to calculations, KPIs, actions, partitions, aggregations, and perspectives. Then translations. Clear? Okay. Right. Then let's close the session for today. Have a nice